Okay.
It's always going to be negative.
It's always going to be negative. And acceleration is always negative in that case because gravity pulls things which way?
To the center.
Down. Woo. It's supposed to start raining.
It was raining It's raining right now. Our game's going to be canceled.
We're just going to make a wedge.
Okay.
What's he going to do?
I'm going to do some speed physics here. I'm going to try to make this easy to understand, but I'm going to go really fast and see how fast I can go without screwing up. So the first one, the zip line, did I give you data or did you find your own? You found your own. So this is my data. It took 4.7 seconds and it went 9.5 meters, and I'm supposed to figure out the acceleration. So I'm just going to see what I've got and see what I'm looking for. I'm looking for A, and I've got D and T. So I look through my formulas, look for something that gives me A. There are two possibilities. There's one that has D and T in it. So that's the formula I use, 2D over T squared. A equals 2D over T squared. And then I just substitute my stuff in there, 2 times 9.5 divided by the time squared. And here I'm going to cheat a little bit. I'm not actually going to write it out, but first you multiply this times that.
Wait, distance is over velocity.
What?
Distance is over velocity.
What's over velocity?
Triangle, distance.
Yeah.
So you divide.
But I don't need the triangle for this one.
Well, I'm doing it.
Yeah, okay. Ooh, okay. Confuse me. So first you multiply these two together. I don't have my calculator. So, anybody want to? Nah, I'm just going to write down what the answer is. 2 times that divided by that gives me 0.86. So that's the acceleration, 0.86 meters per second squared. You may have had a different number because you had different time and distance. Now for this next one, the meter stick is sliding. It starts here, you slide it over this way, and then it stops. And you get a time, you get a distance, and you come up with an acceleration. So again, I'm looking for acceleration. I have D and T. So I look at my formulas here. There are 2 that give me acceleration. This one asks for V and T. That's not helpful. So it's that same formula again. A equals 2D over T squared. These formulas will be on the test, so you can just follow this. Look at what you need. Look at what you're going for, and you can find the right formula. So in this case, it's 2 times 8.7 divided by 2.7 seconds squared. So multiply these two together, square that, and then divide whatever you got here by whatever you got there. And when I did it, I got 2.4 meters per second squared. You probably got something between 2 and 3, or maybe between 1.5 and 5. That's okay. That's an acceptable range. Now, in these next problems, we should get the same answer because it's not relying on data from there. So somebody's throwing a ball in the air. This is the hardest problem. I don't know why I put it third. I mentioned there were 3 tricky things. When something is flying through the air, the first thing is analyze the downward trip. So remember that. Just focus on what's happening when it's falling, and you'll be okay. Second, acceleration the whole time when something is in the air is always negative 10 meters per second squared. And the third tricky thing to remember is downward equals negative. So if you can keep those 3 things straight, this isn't very hard. If what I'm saying is going fast, you can go back and watch this video when I post it later today. So, or ask me questions, I don't mind. The ball stays in the air for a total of 10 seconds. How high does it go? We're not going to figure out how high it goes. We're going to figure out how far it falls. Same thing, right? Okay with that? Okay. Because analyze the downward trip and everything will make sense. we know we can figure out the time. Stays in the air for 10 seconds. So if this is 0 seconds, this would be 10 seconds. What's the time up there at the top? 5 seconds. So the important amount of time here is that this fall takes 5 seconds. I'm going to put 5 seconds in for the time because we're just looking at the downward trip, not the up and the down. That's the first tricky thing over here. The acceleration is negative 10 meters per second squared. So I've filled in the stuff that I need. Now I can get the distance. I just have to find out what formula is going to give me that. So looking at my formulas, here's one for distance. Here's one for distance. But I need one that gives me distance based on A and T. Not, this one won't work because it asks for V. So this is the formula that I need, 1/2 AT squared. I'll write it over here. D equals 1/2 AT squared. And now I'm just going to plug stuff in. 1/2 times negative 10 meters per second squared times 5 seconds squared. And this isn't very hard math. So I'm going to do this first. 1/2 times negative 10 is negative 5. And that's multiplied by this squared. This squared is 25. Or it's 25 seconds squared now. Negative 5 times 25 is negative 125, and it's going to be meters. So I've got a negative answer. Why is it negative?
It's going down.
It's going down. What I've been finding is, what's the distance that this is? I'm just focusing on this trip. So yeah, the distance we get is going to be a negative one because it's going down. But the question was, how high does it go? So I'm not going to write negative. I'm just going to write 125. And you may have done that in a different way without the negatives in there and still gotten the right answer, and that's okay. If you know what's going on. Yeah.
Do any of these problems have a radical in them?
They should not. I mean, well, yeah, but go ahead and figure out what the square root is. So just give me a decimal answer. Don't give me a radical.
Oh, jeez.
Now the grouse, this is a straightforward one. There's no, it's not a ball in the air. It's just something going a certain distance over a certain time. So we've got something to go 60 meters in 8 seconds, 60 meters, 8 seconds. I want the velocity of that grouse, so I just go looking in my formulas for V. I could use this one or this one, and that's it. But I have D and T, so this one's not going to work. It's based on A and T, so I need to use that one. Velocity equals distance over time, which is 60 meters over 8 seconds, and that gives me 7.5 seconds. Yeah, meters per second. Thank you, Matt. It's velocity. Don't forget to put the units on. By the way, I always mess up on my tests. So if you're not perfect and you do stupid stuff like I just did, don't feel too bad. Everybody does it. Number 5, how long does it take to go 200 miles if you have a velocity of 60 miles per hour? That's the distance. These are just straightforward. If you don't have a ball in the air, if you don't have something that it says is accelerating or speeding up, if you don't have something that's being dropped, then you don't have to worry about acceleration. These are just much easier. There's the velocity. And so I'm looking for a formula for time based on D and V. And I've got 3 formulas for time. The only one that's based on D and V is that one. Time is distance divided by velocity. So time is 200 miles over, I should write time equals D over V. Write my formula. 60 miles per hour. And that gives me 3.33 hours, or you could say 3 hours, 20 minutes, 3 1/3 hours. Number 6. Okay, now we've got you drop a rock off a very high bridge. So this is a mildly tricky one again because we've got something falling from the sky. We've got to remember what the acceleration always is. We've got to remember if it's going down, that's going to be negative movement. So we're going to have negative numbers for how far it's going and how fast it's going and things like that. Let's see what we've got so far. We've got 8 seconds after you release the rock, you see a splash. That's the time. The acceleration doesn't tell us anywhere in there, but we know it. It is what? Negative 10 meters per second squared. Now, if you put 10 in there, I'm not going to take off points. As long as you get the right answer here, I'm not too picky about it. But it's smart to put the minus in there. Yeah, so some of you, if you know what acceleration means, you don't really need the formula. You can just say every second it's going to speed up by 10 meters per second, so 8 seconds it's going to be going 80. Or you can say, I want the velocity, I've got these two things, I'm just going to trust my formulas. Velocity equals distance over time, that's no use because it doesn't have a and t. So this one, this is the one where velocity equals at. I can use that. Velocity equals at. A is negative 10. T is 8 seconds. And that's going to be 80 meters per second. Sorry, negative 80. If you give me the answer of 80 meters per second here, I won't take off points unless I specifically asked what's the direction and the actual speed. So, although it's better to say that, I'm not going to take off points on the test. How long does it take a cannonball to fall 700 meters? Again, you've got something falling, so it's going to look like there's not enough information because I'm not giving you acceleration. 700 meters, that's the distance it falls. And really, since something is going down, I should not write 700 meters. What should I write? Negative 700, because it's traveling 700 meters downward. But if you don't do that, you're going to wind up with some funny, you're going to have to take the square root of a negative number. And you just can't do that. The acceleration is negative 10 meters per second squared. And now if you just decided the distance is 700 and the acceleration is 10, that's going to work out and you're going to get the right answer. So you can do that if you know what you're doing.
Is this where you have to do the t equals radical d or 2d?
Yeah, so we're looking for the time and we have acceleration and distance. The only formula on this sheet that gives us time in terms of distance and acceleration is this one. So this is the square root of all that stuff. You do all that stuff first and then you take the square root of it. So it's time equals square root of 2d over a, and that is the square root of 2 times negative 700 meters divided by negative 10 meters per second squared. And let me just move it to up here. Square root of negative 1,400 divided by negative 10 meters per second squared. And running out of room. Square root of 140 seconds squared. Yeah, and what I would do at this point is just on your calculator type 140 square root or square root 140, whatever order you have to do it in on your calculator. And on these calculators up here, I think you have to hit the square root symbol and then type in 140 and then enter or equal. And the answer is 11.83, 11.8 seconds. Other than getting the right formula and getting the right numbers, the key is to do it in the right order. You've got to do all of the multiplication and division before you take the square root. So taking the square root is the last step on that. Number 8, this is a little different than the other ones. Cars traveling at a speed of 22 meters per second, and over a time of 4 seconds, the car speeds up to 30 meters per second. Let's start filling stuff in. So what's the time? 4 seconds. Now this means change in velocity. So the velocity change goes from 22 to 30, so it's 8 meters per second. So we need to look for an acceleration formula that's based on velocity and time. And the only thing that looks similar is this. It says acceleration is change in velocity divided by change in time. That's really what this is. It just doesn't say change in time, it says time. So plug the stuff in. Change in velocity is 8 meters per second divided by 4 seconds, and you get 2 meters per second squared. Okay. Last one is another ball one. Something's going up, something's going down. On the ball ones, always focus on the down trip. The reason we can do that is because we know it's going 0 meters per second at the top, and it's going really fast at the bottom. It says it's thrown with a velocity of 35 meters per second. How long will the ball stay in the air? That presents a little bit of a problem here, because I don't really want that. That's the velocity right here. I want to use the velocity on the downside. So what's the velocity there going to be? Negative 35. Again, you could do this with all positives and you can get the right answer, but I'm just showing you this is the formal way to do it. This is the way it'll always work if you do everything properly. You can do it improperly as long as you know how to do it improperly and get the right answer. So the velocity in this case, we're just focusing on the down trip, is negative 35. The acceleration, hey, what's that? It's not given.
10 meters.
Negative 10, because it's something that's falling. And then I'm looking for time. So formula for time with velocity and acceleration. Of these three time formulas, this is the only one. It's velocity divided by acceleration. So it's going to be negative 35 meters per second divided by negative 10 meters per second squared, which gives me 3.5 seconds, and that's not the
You
answer.
gotta double that, man.
Yeah, this is the fall time. That's the time to make it fall. So to figure out how long it was in the air, 2 times 3.5 gives me 7 seconds. Anybody have any questions about any of that stuff? All right.